All right, fantastic. Hello, yeah, my name is Jerry Berger. I'm with Electro Chemical Devices, and today we're going to talk about the family of products that's offered by ECD. ECD has been in business since the mid-70s, so we've got a lot of experience on pH, conductivity, things like that. We're a manufacturer of analytical instrumentation to monitor and control aqueous solutions. Today we're going to start with a short PowerPoint. The PowerPoints are our latest two transmitters. Our family of smart transmitters, universal transmitters. One of them is our T80, which is our general purpose instrument, and we're going to be using that for most of the demonstration we do today. And then we've also got our X80, which is an FM approved and ATEX approved for hazardous installations. So after the PowerPoint on the transmitters, which is basically going to focus just on the transmitters, we're going to go ahead and look at some of the sensors we've got and the technologies we're using there and what kind of differentiates us from everybody else. So let's go ahead and start with our PowerPoint here. And we're going to look at, like I said, the T80 and X80 transmitters. Okay. All right, so the X80 is the one on the left, and the T80 is on the right. And as I said, the X80 is FM and ATEX approved. The T80 is a general purpose instrument. The menu structuring in the two transmitters are identical. So one of them on the X80, you're using magnetic switches through the glass. The T80, you have push buttons on the front display, but the configuration of the buttons and the software is the same. So if you know how to use one, you know how to use them both. Transmitters, one transmitter for multiple process measurements. So you can do any of the measurements from pH, ORP, dissolved oxygen, any of the selective ions, conductivity, resistivity, turbidity, and chlorine, all with the same instrument. Whatever sensor you attach to this transmitter, that's what it becomes. No hardware or software changes between the different measurements. The T80 was designed to be a very simple to use transmitter. It's menu structure. It's all done in a menu structure with soft key choices to migrate through the menus. So the keys change what they do as you do different processes. So if you wanted to calibrate, you follow the key structure for the calibration. If you want to configure something, you go through those key structures. Very simple to use. Once you push the buttons a few times on it, you'll understand and be very comfortable with the transmitter and its simplicity. It's got a large, easy to read LCD display also. Showing the display shows the process variable, percentage of output, temperature. If has relays, it will also show the state of the relays. The inputs on the T80 transmitter, it can do up to two sensors. Any of the intelligent sensors that we've already taught, that we showed that one screen of. With outputs, a standard output is a 4 to 20 milliamp output with Modbus. Optional, you can get a second 4 to 20 output. You can get Hart 7, and there are 3 relay contacts that are also optional. Power requirements on the transmitter, we can do it 3 different ways. You can do it with a loop power transmitter. That's only a single channel instrument then, or you can do 24-volt DC powered, where we can do 2 channels, 2 in and 2 out, and AC powered. The X80, as I said, it's the same as the T80. The only difference is it uses an S88 sensor instead of the S80, and the reason for that is because there's a barrier included. And depending on if you're going FM or ATEX, there are 2 different barriers. We'll show those later on in the day when we're wandering down my wall of instrumentation behind me. The X80 is FM or ATEX approved for hazardous location installation. It is loop powered or 24-volt DC powered. Has 4 to 20 milliamp output, and Modbus is standard option, same as the T80. It's got optional heart, and it does have 3 relay contacts, and it comes in a stainless steel enclosure. This is the FM approved barrier. It's a B88 barrier, and it's got a special connector for the sensor cable to attach to that barrier. And then below it, I've got an installation drawing kind of showing how to wire up the X80 per FM and showing a 2-channel instrument. The S80 sensors, which we'll get into more detail as a little bit later in this presentation, but it's digital communication. So between the sensor and the transmitter, we're digitally communicating instead of just millivolts, making them less susceptible to noise and interference. Also allows us to put a microprocessor in the sensor, which stores the sensor type, the serial number, process variable, calibration data. So when you wire up the sensor to the transmitter, it uploads all that data to the transmitter, making the transmitter whatever the sensor is. So if you hook a pH sensor up to it, it becomes a pH instrument. If you hook up a connectivity sensor, it becomes a connectivity transmitter. No changes to the transmitter. Also, the calibration data, since it's uploading the calibration data, you can calibrate the sensor on a bench in your lab and then take it out and just attach it to the transmitter, and it'll upload the data and be calibrated. You don't have to perform the calibration in the field. The sensor comes available with a potted-in style cable or an IP68 rated detachable connector. We'll show those again a little bit later, the actual connector. And the connector comes in handy when you're going to calibrate on a bench and then take it out and attach it to the transmitter. So that's just a quick, brief overview of both the X80 and the T80 transmitters and the capabilities of them. And the real technology is going into the sensors, because that's what's got to live in your process. So we'll go a little bit more detail in those two, in the sensors themselves. So that concludes the PowerPoint presentation in this webinar.
Unmuted.
Okay,
so I will send it back to you there.
Yeah, this is a good time to we'll take a little break and see if there's any questions. I'm going to look at the chat log here, and then also invite folks to submit any questions they have. Our first question, well, we have one question so far. It's just, how much is the cost of a replacement electrode? I know we're going to show them, get into that, but might as well.
Well, it depends. It depends a little bit on the process variable you're looking at. If we're talking about pH, the general purpose pH electrode is $180.
Okay.
We've got a few different electrodes. They range up to, about 250 for some of the more exotics when we start talking about different types of glass and reference and things like that.
Okay. Okay. A couple more questions are coming in now. We appreciate the questions, guys, so feel free to ask anything you run into, anything specific, fire away. So this one is, what are the pressure and temperature ratings of the pH sensors?
Well, that depends on how you're installing it. As you see, we'll get later on in the presentation when we show the sensors. We've got a valve retractable version that can handle higher pressure, and the insertion style, which doesn't really handle the pressure just because of how it's installed in the process. But we can get up to 100 C with our standard sensors, and we can get you the specifications as far as the pressure on the two different installations.
All right. Let's see, one more here right now.
What about the high temperature? How high can we go?
The high temperature, when we remove all the electronics from the sensors, we can get higher. With an S80, removing the electronics, we can get up to about 130 C. And we've got pH electrodes that can handle that kind of temperature. They don't last as long at those kind of temperatures. So typically I recommend trying to lower the temperature if you can, but if you can't, we do have equipment that can handle those temperatures. It just requires more maintenance than the lower temperature sensors.
Okay. How long will the pH sensors last in an average application?
Yeah, that's always going to be application specific, but taking something like a cooling tower, you're going to get a year to a year and a half out of an electrode. I typically tell people as a rule of thumb, annually replace anyways. And then you could look at some of the, like a sulfide scrubber, where you get, 3 to 6 months. So it really depends on the application.
Okay. Kind of answered. Well, how often do we calibrate the pH sensor, and is there any auto calibration on the units?
Well, again, calibration is going to be application specific, but a good rule of thumb is probably, monthly checks and calibration on it when needed. And it's got what we call an auto cal, which is just recognizing the solution that the sensor's in. It doesn't have anything that would calibrate, quarterly, because you've got to put solutions on it. So you take the sensors out, you put them in the 2 solutions, and do a quick calibration on it.
Mm-hmm. On that, does it require a 2-point or single-point calibration?
Recommended 2-point, then you're calibrating for both an offset and the efficiency of the sensor. But you can also do standardization if the slope of the sensor is still good. Okay. Because typical degradation of pH, ORP, selective ion, all those things, typical degradation is contamination of the reference half cell, which is going to cause an offset in the reading.
Okay. Last one. Are you seeing ORP measurement more in wastewater applications?
Depends, because ORP is very useful measurement, but it doesn't tell you anything specific. You have to understand what you're looking for. So you can use ORP to tell you if you're in an aerated situation or an anoxic situation. So ORP's got a lot of useful readings in wastewater, and we see a little bit of it there.
All right. Thank you guys for the questions. That's all that we have right now. So Jerry, it looks good. The cameras looks good. So
okay.
I'll let you go through the different setups you have here for us.
All right. So we're going to just look at a few of the systems I've got here behind me. We're going to start with our chlorine analyzer right here. It comes in a complete panel assembly with everything needed to make a good, clean measurement. We're using an amperometric chlorine sensor for both free and total chlorine. So the 3 things that cause issues with doing this type of measurement, one is flow. Since it's a consumptive sensor, if you change the flow on it, it'll change the way it's reading, and you may not get an accurate. So you want to make sure you've got a constant flow. We're taking care of that with our what we call a constant head flow controller. It's just a simple overflow device. So it keeps my pressure and flow through the system constant. Anything anywhere between 8 and 80 gallons per hour going into this constant head flow controller will stay constant through the system. So that's number 1. Number 2 is an influence is pH. We've got a pH sensor on the system, so we're taking care of that. And the pH sensor is the same as the standard one we're going to see in a little bit as we go down, but it's just my standard insertion style pH sensor. And then we've also got temperature interference. So temperature, we are temperature compensating. So changes in temperature will change in the way the unit reads. So we're taking care of that. So the 3 things that impact measuring with an amperometric sensor, we're taking into consideration on this panel. So what we tell everybody is you just run this, you run electricity to the transmitter, run water to the constant head flow controller, make sure that it's overflowing, and let this thing run for a while, and it'll come up working pretty well for you. And it's got chlorine sensor right here, also in a flow cell assembly. This one is a free chlorine sensor. I've got another demo here of the free chlorine sensor. I can get a little closer. That one is a free chlorine sensor. This panel will do free chlorine or total chlorine depending on what sensor you've got in there. The free chlorine sensor, the maintenance on it is periodically refilling the electrolyte. And to do that, you remove the cap, you dump out the electrolyte that's in there, and you refill it. You can polish up the gold end on it to improve efficiency on the system. Put it back together, and you put that back in there. Now, as far as replacement and refill on the the free chlorine, you're looking at refilling and doing that every, let's say, 6 to 8 months. You're going to refill it under normal operation. It does depend on a few things as far as the concentration of chlorine that's running by it and the pH, because a free chlorine sensor only sees neutrally charged molecules, so it only sees the hypochlorous acid. So the lower your pH is, the more this is going to see, and the faster the electrolyte will deplete. It's got the pH sensor that sees the rest of it. So we've got a program in here that looks at the hypochlorous acid and then looks at the pH and knows how much of the hypochlorite ion is present and gives you a total free chlorine reading. We also can do, as I said, you can do total chlorine on it. The sensor is a little bit different for my total chlorine sensor, and but it works the same way. It's still pH compensated, and it is still temperature and flow is taken care of. Periodic on here, you're going to again refill it. You just refill the membrane cap, and then periodically you will replace this membrane cap. And on the total chlorine, again, depending on the concentration, you're going to be refilling that guy every 4 to 6 months probably, and replacing the membrane every 2 to 3 times that you refill it. So a membrane replacement kit comes with both the electrolyte and a membrane cap. So it's good for basically 1 year on the maintenance. So that's the chlorine analyzer. Along with chlorine, this system will also work for a few other oxidants. It works for ozone, parasitic acid, hydrogen peroxide, and chlorine dioxide, depending on what you're measuring. And the only thing that we're changing for any of those measurements is the actual chlorine sensor itself. So we put a different sensor in there, we can measure different things. But the rest of this panel stays the same. Okay? We'll move on down here a little bit. And here we've got our dissolved oxygen. When we're talking about dissolved oxygen, there's a few different ways you can do, a few different technologies you can use there also. We're going to look at the 2 technologies offered by ECD. First, this is a galvanic DO sensor. It's the way it was done for many, many years. Still a very viable measurement. A little bit less expensive than the optical, which we'll talk about in a second. We use the galvanic cell Teflon coated membrane with lead and silver behind the membrane. Oxygen crosses the membrane, creates a chemical reaction, and we measure that chemical reaction. We use the galvanic style in the part per billion measurement. It's far more accurate than the optical at the very low levels. So that's typically where we use it, but it does still, the sensor itself goes all the way up to 20 part per million, down to less than 1 part per million, depending on the environment that it's installed in. And that's why this one's in a stainless steel flow cell, because it's, like I said, it's typically we use it for part per billion, and you got to control the speed or the flow, pressure, and make sure no oxygen's getting in there. So we've got it sealed up in a stainless steel flow cell. Okay, as we move down our wall here, we're going to get to our optical DO sensor. This one's an optical transmitter. It's got our optical DO sensor. The maintenance on an optical DO sensor is very simple. They're very accurate. They're very reliable, typically in the part per million measurements. This is designed for aeration basins. It works very well down to about 200 part per billion. Below that, I would go to galvanic. Above that, you can use this very well. Replacement on this is a membrane cap. The optically active component is this cap. So you're going to be replacing this cap probably every 2 to 3 years. So that is the only maintenance on it. The sensor itself, as far as calibration, it's just you pull it out of the process, you clean it up, put it in air, make sure the humidity is 100%, and do an air calibration on it. The transmitter itself does everything else for you. It does the elevation compensation and temperature compensation during calibration to come up with what your total saturation is in air. So it's very simple to use. They're accurate, they're reliable, and that thing's fun. They're really simple to use with little to no maintenance.
Jerry, it looks like we have
Yep.
a question here.
Okay.
That could be a good time to stop for a second and ask some questions.
Sure.
I also want to remind folks, if you can't see Jerry's full screen, there's a drop-down button in the middle of the GoToMeeting, and just click View Active Cameras. I think most folks saw that. But first question, if I have a process that needs both pH measurement and a temperature measurement, is there any way to get both outputs from your transmitter?
Yes, the transmitter has up to 2 to 20 milliamp outputs. So yeah, you could, the pH sensor is doing pH compensation. So it's taking a temperature measurement back to the transmitter for that function. And you certainly can get a 4 to 20 assigned to that temperature measurement so you can get both variables, yes.
Okay. Is the chlorine sensor, well, on that question, what primary sensors also have the ability to measure temperature?
The sensors, all of our sensors incorporate temperature. So any one of the sensors we're looking at today have a temperature sensor built into them, so would allow you to monitor temperature also.
Okay. Another one, is the chlorine sensor a real-time measurement, or is there any lag for sample analysis?
No, it's a continuous measurement, continually updating to whatever process flow is to it. So the only lag would be on the sample getting to the transmitter. So if you've got a long run of the piping from your process to the analyzer, that would be the only lag.
All right. About any reagents?
For the chlorine measurement?
Yes, I believe so. Yes.
Okay. No. You are adding nothing to the process. There are electrolytes that are inside the sensor behind the membrane that facilitate the chemical reaction, but to the process, no, you're adding nothing to the process.
All right. Okay, we can keep going.
Okay. So let's see here. We were going to move down here further. Right now, we'll just take a look at the PA or the conductivity. The next sensor we come up to is conductivity. That's on this unit right here. And we offer 3 different styles of conductivity sensors. One is our standard contacting conductivity sensor. And this sensor is usable from 1 microsiemen up to 50 millisiemen or 50,000 microsiemen. It's auto-ranging, so it's the same sensor regardless of where you're measuring. We just recommend, since it's such a wide range, that you do your calibration somewhere near where you're looking to measure so that you optimize the reading at where your measurement point is. So if you were going to be measuring 3 to 7,000 microsiemen, you might want to calibrate at 10 millisiemen or 10,000 microsiemen. If you were going to be measuring down at 100 microsiemen, you might want to calibrate down at you know, a couple hundred microsiemen just to, again, optimize it for the range wherever you're looking to measure. But it is one sensor, auto-ranging function from 1 microsiemen to 50 millisiemen. If you're looking to go below 1 microsiemen, we've got a slightly different sensor. It's got a different cell constant on it, and it's designed actually as a resistivity sensor, but you can turn it to the inverse and make it read low conductivity. So if you're less than 1 microsiemen, this is the configuration sensor that you would use. It'll go up to about 10 microsiemen, but that's about as high as it'll go. It's really designed for low, ultra pure water. There are no replaceable components anywhere in those sensors. They are solid, encapsulated, and potted and ready to go. The other version of conductivity sensor we've got is what we call a toroidal, or a non-contacting conductivity sensor. This sensor is usable for high conductivity. It actually will go up over 1 Siemen, and it will also read down to about 300 microsiemen. So it's got a good range on it also. Again, it does auto-ranging function in it. And same as with the standard contacting, we recommend calibrating this unit within the range you're expecting to read it. So if you're reading up at 100 millisiemen, that's where you want to calibrate it, up around 100 millisiemen, just to optimize its functionality at the higher ranges. Okay, and those are, as I'm showing you these sensors, all the sensors that I'm showing you are insertion style. We will, when we get to the end of this, I will go through our other sensor, the valve retractable one, and that sensor allows you to install the sensors into a pressurized or a flowing line without having to shut things down to get it out. And we'll look at that whenever we're finished, but the sensors we're looking at here are all my insertion style. Mm-hmm. Okay, so that concludes the conductivity there. We'll slide down here a little bit further, and the next one we're looking at here is turbidity. As I said, the universal transmitter, it also does turbidity, and we actually, at the beginning of this year, brought out our brand new turbidity sensors, what we're showing here, and it's our TR80 and TR82 turbidity sensors. The only difference between the 82 and the 80 is one has a wiper and one doesn't. The 82 does not have the wiper, the 80 has the wiper. The demo here I've got here that I'll show you is the one without the wiper. But installation on that, this is a debubbler function, so if you're very low turbidity, you want to make sure the bubbles are not present. So we've got what we call a debubbler. And that's just a bubble trap that allows the process to relieve the bubbles before the measurement, so you don't get interference with that, because the turbidity sensor will see the bubbles exactly the same way that it sees turbidity. So as I drop my one sensor, now this is the sensor outside of the debubbler. It's a flat surface on the front, so you don't get a lot of buildup and things sticking to it, but it is a nephelometric turbidity measurement, so it is measuring at a 90-degree scattered light. It's just the way the lights are positioned inside the sensor, it's making the measurement right at the surface of the sensor at a 90-degree scattered light. This sensor here, I've got a compression fitting on it, and that's just a fitting, so you can install this by installing a standpipe on it, and you could go straight into the process using a PVC standpipe, or you can use a debubbler, or you can use a flow cell, depending on how you want to install it. The sensor is flexible on its installation. This one, like I said, does not have the wiper. The only difference is the other one would have an auto wiper. The automatic wiper works really well, but it's kind of like a windshield wiper on your car. If you've got greases and fats that are building up on it, the wiper is just going to smear it, so that's going to take more of a mechanical cleaning, or a spray nozzle. For this model sensor, we do have a spray nozzle that can be attached to the front to spray it off with water or air or something that would clear off whatever's building up on the sensor. And that spray nozzle can be controlled through the relays and the timers in the T80 to spray every you know, 3 hours, 2 hours, whatever you need to do to keep the sensors clean. So the turbidity sensors allow you to do that. Okay. And as we move down a little bit further, we'll get to the pH. Okay, so this one's doing pH, and again, we talked a little bit about pH. This is my pH sensor. Again, it's a standard insertion style sensor. It goes through a 3/4 inch compression fitting. So if you're going to go into a pipe or something, you can mount the fitting with the threads forward. If you're going to put it onto a standpipe, you can turn the fitting over and go the other direction and install it on a standpipe and off of a handrail. So the sensor is very flexible in its installation. The cartridge that we've been talking about a little bit, let me get my little wrench here, is right here at the front. So when it becomes time to replace an electrode, the sensor, you keep all the sensor installed, take it out, you remove this cartridge. There's my cartridge. Get it in front of the camera. That's the cartridge. So you take that, you throw that away, you install a new one. It's that simple. When you replace the cartridge, you're replacing everything that's needed for the process measurement. You're replacing the reference junction, the fill solution, the silver chloride wire, the glass, everything needed for the measurement is replaced simply like that. And the pH electrode runs general purpose, $180. Most of the other sensors out there on the market, you're replacing the entire sensor assembly, which means you're running new cable, things like that. So it's time and expensive. These sensors there run typically around $400 or more, depending on what kind of exotic you're getting into. The ECD design allows you to replace an electrode. So let's say that originally you use our general purpose pH electrode and it doesn't give us the life in the process we were expecting. We ask a lot of questions about your application, but then it allows us to change the electrodes. So we've got probably about 30 different pH electrodes with different configurations that allow us to better engineer a sensor to outlast anything else in the process. So you can see this one here. This is my general purpose electrode like we just showed. It's flat glass, Teflon junction, a Radel body. It does have 2 junctions in here, but it's just a general purpose KCl fill solution. We've got this one. This one's flat glass, but it's got a peak body. So if you've got a solvent or something present, the Radel is not all that good, we can go to peak, or some acids. We can go to peak. We can also change the guard configuration to give us more protection if you've got solids coming through the line that could break the glass. So this is a full crown protection, whereas these are just 2-time. We've also got a configuration, you saw those were flat glass. This one has a bulb on it. Gives us more surface area, a faster response. It's not a whole lot faster, but it is a little bit faster, and it's really designed more for when you're in high purity water, things like that. You want as much surface area as you can possibly put on it. So we've got the Hemi style or full bulb glass configurations. Along with the glass, we can also change the fill solution. We can change the junctions from the Teflon to a ceramic to a Kynar, depending on what's best for your application. So ECD will design a sensor for you to outlast anything else that you've had in your process before. So we can do that with the materials of construction on the electrodes. We can outlast them. And if for whatever reason the electrode that you originally get out there doesn't give us the life we're looking for, you send that electrode back to me. I have my chemists open it up. We find out what happened to it. And then we look at the vast array of electrodes we've got, and maybe we've got one that would work better for the application. We get that out to you. It screws in exactly the same way as the original one came out, because the actual body is the same on the electrodes, the same shape and size. So we can change the type of electrode that you're using to hopefully extend the process life and accuracy of the measurement. Also, when you replace the electrode, it also replaces the O-ring seals. To seal the electrode, we've got 2 stagnant seals and 1 compression seal that seal on the stainless steel housing and gives you a good seal so all the electronics inside the sensor are all safe and do not get any moisture up into the sensors. So that covers most of pH. Like I said, we will talk a little bit more about the different sensor configurations that we can do. So, all right, so if we move down just a little bit here, we're going to get to our ORP. There was a question earlier on the ORP. The ORP sensor looks exactly like the pH sensor. The body itself is exactly the same. The only difference is the measurement half cell that we're using on this sensor. This one is an ORP electrode as opposed to the pH electrode. So you can saw the pH electrode had glass. That's the measurement half cell on a pH electrode is glass. The measurement half cell on an ORP sensor is platinum. So the only difference between this electrode and a pH electrode is that the platinum. Again, but we can replace it just as easily. Comes out, you replace your O-rings, everything else is replaced, the measurement half cell, the reference half cell, everything needed for the measurement is replaced. Simple, easy replacements. And we can also do some changes on this one. We're not going to change. We do have a couple of different configurations for the platinum, depending on if you're getting a buildup or things like that. We can change the fill solution. We can change the reference junction if needed. So that is an ORP sensor. Simple to use, the same configuration. This same configuration also works for selective ion. We measure a lot of different selective ions. The typical ones that we measure a lot of is fluoride, sulfide, calcium, and sodium. Those are kind of the ones that we sell most of. They come in the same configuration. The sensor itself is exactly the same. The only difference is the measurement half cell. So we replace that measurement half cell the same way. The electrode is exactly the same. We've got a little bit different design for 2 other selective ions that we measure. We measure ammonium and we measure nitrate. And for those measurements, there are other interferences you need to take into consideration. For ammonium, most of the time in a wastewater you're looking for ammonia, not ammonium, but ammonia and ammonium is a pH relationship. So in the lower pHs, there's more ammonium than there is ammonia. So instead of having to raise the pH up to measure that, we actually developed our sensor, which is called a Hydra. The Hydra has 3 different measurements inside of it. So for an ammonium sensor, we can measure ammonium, and then we have a pH measurement on there also, so we know where on the scale it is, so we know how much ammonium and how much ammonia is there, and we can display on the instrument total ammonia, or ammonium, or just ammonium, or just ammonia. So we can do different variations in order to get the measurement that you're looking for. So this sensor here, it's all 3 sensors built into one. And it's got a spray nozzle in the front to knock out anything that gets stuck inside that you can periodically run. But removing the electrodes are exactly the same as they were in the pH sensor that we just looked at. You just remove them like that. So there's the pH electrode out of there. You remove that and replace it. If you want to remove and replace the ammonium sensor, the same way. You remove and replace the ammonium sensor. And the ammonium sensor, missing the sensor, has got a PVC membrane on the front that has an affinity for the ammonium ion. So that's easily replaceable also. So they replace out of this sensor. This is also just a guard configuration that can come off to get to the sensors a little easier. So you can replace, if one of these electrodes fails or requires replacement, you can replace the one that's causing the issue. And then you can see that it's got the spray nozzle right there. The same with nitrate. You can do it this way also, but nitrate really only has an interfering ion. The pH doesn't have any effect on it. So you can go with the Hydra, or you can just go with 2 selective ions, and we can compensate for the interfering ion on the nitrate. And so that covers the Hydra, and it covers the selective ion sensors. If we can measure it with an electrode, we can make an electrode to do it. As I said, fluoride and sulfide and calcium are probably the top ones that we do. Ammonium and nitrate come in very close to that also, thanks to the Hydra configuration. But there are others that we can do. We can do lead, silver, things like that too if you need to. So just let you know that we do have a good variety of selective ion type sensors.
Jerry, a couple questions.
Yep.
First question, do you sell spray nozzle cleaner for the pH probes like you do for turbidity?
Yes, we do have the spray nozzle. I don't think I have one here sitting here. I should have, but I don't. But yeah, it's just an attachment to the front of the sensor that compression fitting. You would turn the compression fitting around, and the spray nozzle attaches to the threads on the compression fitting, so you can attach it to the front that way. So yes, we do, and just like with the turbidity, the spray nozzle can be controlled through the transmitter, relays and timers.
Okay. Do you offer non-metallic sensor housings?
We do. The sensor materials of construction we offer as a standard stainless steel. We offer as options, we have titanium and hastelloy. If none of those 3 metallic housings would work, we do offer polypropylene and kynar. There's some downsides to go into polymer. You lose the solution ground. The metallic housings have a solution ground, so it keeps everything at the same potential. The polymer does not have that, so it does have susceptible to noise coming in if you're at different potentials. But we do offer kynar and polypropylene if needed.
Okay, great. Okay, that's all the questions, so we can keep going. Looks like explosion proof.
All right, so as I said, we have the explosion proof transmitter also. That's my X80. The X80 transmitter, exactly the same as my T80 as far as the button configuration and the operation of it. You can do 2 inputs on this one also. With 2 outputs, you can do Modbus and HART. The only difference here is the sensors. The sensors require a barrier. For ATEX, here's the barrier right here. It's attached to the bottom of the transmitter. For FM, we have a different barrier. It's our B88 barrier for the FM approved. So depending on what approval you're looking for, FM or ATEX, would determine the barrier that's used. Other than that, the sensors are the same. There's a different, obviously, there's a connector that needs to be on them, so they're different with the connector. But other than that, the sensor configuration, as far as valve retractable or insertion style, are exactly the same. The materials of construction are the same. The electrodes are the same. Everything is identical, except for we've got a barrier on these.
Okay, and the magnetic push buttons as well, right? For the
it's a the magnetic instead of standard menu push buttons, right? So, all right. So I said that we would look at the valve retractable sensor. We looked at the first one here. We're looking at our insertion style. So this guy right here, this is the one we've been looking at on all the applications so far. And it does have, like I said, the quick disconnect connector on it. It's an IP68 connector. You can disconnect the sensor from the transmitter. You take this back, you install it onto a transmitter in your lab. You can calibrate it, configure it, clean it, do whatever you need to do, and then take it back out into the application, and you just snap it back on, and it's now uploading all its data back to the transmitter, and you've got it calibrated sensor out in the field. So if it's I've got a customer that in New Jersey, and it's certain times of the year too cold, doesn't want to be out there calibrating, so he's got 2 sets of sensors, and every week he goes out there and he changes the sensor, and then over the week he cleans and calibrates them and has them ready to go for the following week. And he just goes out there and takes them off, snaps the new one on, and goes about his way. So he's done calibrating and configuring very quickly. The sensor here has got a 3/4 inch compression fitting. This one's stainless steel. Slides off, you turn it over, you can hook a standpipe onto it because we got the threads going back towards the cable. If you put it this way, you can install it into a process line or a bypass line or something like that, or a flow cell. The valve retractable one is right here. It goes through a 1-inch full port ball valve. The sensor is a little bit longer than the other one. The other one runs about 10 inches on a standard. This one runs about 17 inches on a standard. But it's got a 1-inch full port ball valve. It's got safety lanyards on it to make sure that it has a redundancy for it coming out of the valve. But it's also got, I'm not sure how good you can see it, but right here at the front, it's what we call a valve stop. It's actually rolled over material that as you slide this back through the valve, it hits on the fittings, allowing you to close the valve and get the sensor out of the process, or out of the valve for cleaning and calibration. We'll take the handle off real quick. Make sure that if you take the handle off, you can get your safety lanyards off, and no one can open the process while you've got the valve, while you got the sensor out. Sensor comes out of that valve. So there's our 1-inch full port ball valve now closed off, and we've got our sensor out for cleaning and calibration. Electrode is identical to the electrode in the insertion style. The only difference is a little bit longer housing, rolled over front end, and the valve. All the electronics are stored back here. So again, it stores the calibration data and things like that also. And then when it comes time to put it back in, move those fittings up, screw it back on. Put the safety lanyards back on. Get the handle back on. And then you can open up the valve. And then you're sliding the sensor through the valve back into the process. So it's simple, safe, and works very well for processes in a tank that you can't drain the tank from if you're measuring from the bottom, or a process line that you can't turn off in order to do calibration. Because all of these measurements that we're talking about today do require periodic maintenance. They need to be calibrated and cleaned, whereas the conductivity doesn't have anything like the pH electrode that degrades over time like that, but still a coating will affect the conductivity sensor, so it does need to be kept clean. So the valve retraction assembly allows easy removal from the process for cleaning and calibration. We talked about the materials of construction. That is also available in Hastelloy and titanium and polypropylene and Kynar. The only difference between and I don't have a demo here of one, but the polymer housing sensors, when you go polymer, we still need the strength and the shielding from the stainless. So the stainless steel is actually installed into a sheath of the polymer that we're using. So instead of a 3/4 inch housing that's here, the polymer sensors are a 1-inch housing. So they use a 1-inch compression fitting or an 1.5-inch valve assembly in order to use those.
Hey Jerry, we have a question. Also, just a reminder, we have about 10 minutes left. But
okay.
How much does the removable sleeve valve assembly cost?
Depending again on what configuration you're doing, The standard stainless steel with 10 feet of cable runs about $750 for the sensor, and that comes with one electrode. Where the valve retractor, the insertion style one, runs about $500.
Okay, that's was the only question that just pertained to what you're talking about. So,
Okay.
keep going.
Okay, so that's about what I've got to show you today. Unless there's any additional questions, we certainly can get into any details on any of the process measurements that we're doing here, or any of the configurations.
Yeah, so we can give folks a few minutes to formulate any questions they might have. Do you want to briefly talk about part 2 of this presentation coming up?
Yeah. Basically, what we did was we split it up a little bit here because ECD has additional equipment that are standalone analyzers as opposed to the sensor configurations that we went today. And so in a couple weeks, hopefully you can all join us again. We're going to look at TOC, total organic carbon. We've got, looks like my display went to sleep on me. There it is. I don't know if you can see the display on there or not, but we've got a TOC analyzer that we're going to go through the technologies on that. We offer a couple of different ways to measure TOC, and that one is one of them. So we offer a UV254 and a sodium persulfate oxidation method, and we're going to go through in a little detail on those. So in a couple weeks, I'm not sure when Jason's got that one set up, if it's 2 or 3 weeks, but hopefully everybody can join us again.
Yes, I'll be sending out a follow-up email on that, so stay tuned for the TOC part 2 of this presentation. But we've had a few questions come in, so go over those now. Let's see. So first, what's a typical shipment lead time?
Our standard lead time right now is 3 to 4 weeks after receipt of the order, but 90% of our shipments are leaving here in 1 to 2 weeks. If you need something faster, like an electrode, a pH electrode, electrodes have shelf life. They only last so long. We give them a 1-year shelf life. It's a lot like a battery. They start to degrade as soon as they're built. So what I usually recommend is if you've got multiple applications and multiple installations, then maybe having one on the shelf is a good idea in case somebody accidentally drops it or breaks the bulb or something. But as far as regular maintenance, I recommend, letting me know when you're going to do that and placing the order at that time, and we can ship and you'll have the fresh electrode. So an electrode, typically I can get out of here in 1 to 2 days.
Wow, okay. That's good. So question is, do you guys do anything with samplers?
We do have samplers, yes. I didn't go through that today, and we certainly can get together on that one again. But we have a couple of versions of sampler. We've got a portable sampler, and we've got stationary samplers. The stationary samplers are both refrigerated and non-refrigerated, indoor and outdoor installations.
Okay, great. You answered their second question too about portable units. So okay, that's that's all. Were you gonna say something, Jerry? Sorry.
Oh, I was just going to say that the samplers can be configured with multiple bottlers, a sequencer to add at certain time bottles, or you can just have one composite sample, however you want to configure the sampler for.
Okay. All right, guys, that's all the questions. We're going to go ahead and wrap it up. Thank you very much for attending. We appreciate it. Again,